Hello everyone, and welcome back to the Fluctus Channel. The Coast Guard cutter Healey is the largest and most technologically advanced icebreaker in the United States Coast Guard. A 420-foot ship built to push science, security, and rescue operations deep into frozen waters. Commissioned in 1999 and homeported in Seattle, Healey was designed as a medium icebreaker, but its size, laboratories, sensors, winches, and space for scientists make it one of America's most important Arctic platforms. Its hull can continuously break about 4.5 feet of ice at 3 knots, while carrying a permanent crew and as many as 50 mission specialists into waters that few surface ships can safely enter. A Healey deployment begins like a moving expedition. In Nuuk, Greenland, scientists and Coast Guard crews board with equipment, cold weather gear, sampling tools, survival supplies, and research plans for weeks at sea. The ship becomes both transport and laboratory. Inside, passageways connect berthing areas, mess spaces, machinery rooms, bridge controls, science labs, workshops, storage areas, and emergency stations. Scientists prepare instruments while the crew handles navigation, communications, engines, fuel, meals, maintenance, and safety drills. Every person on board must understand that the Arctic is beautiful but unforgiving. So the mission begins with planning, accountability, and constant attention to how quickly ice, wind, and visibility can change. Once Healey reaches the ice, normal ship movement changes. The bow does not simply cut a clean channel like a knife. The ship rides up onto ice, uses its weight to fracture it, then pushes broken floes aside or beneath the hull. On the bridge, watch teams study radar, charts, weather, visibility, and ice thickness. Engineers monitor propulsion load, temperatures, electrical systems, and vibration as the ship grinds forward. Outside, ice cracks, rolls, and separates around the red hull, while the crew adjusts speed and heading to keep momentum without overstressing machinery. Scientific work continues between ice movements. Crews lower instruments over the side, recover samples, launch small boats when conditions allow, and protect delicate equipment from freezing spray. A winch operator, deck supervisor, and scientist may work together for one sample, proving that polar research depends on teamwork as much as technology. Search and rescue is another part of Arctic icebreaker work. When a sailor became trapped aboard a sailboat in Arctic ice near Alaska, Coast Guard personnel used ice-breaking capability and helicopter support to reach a situation that ordinary rescue boats could not handle. Rescue planning begins with location, weather, ice movement, medical risk, and fuel calculations. The ship pushes as close as conditions allow, communication is established, and rescuers prepare for transfer. In polar water, minutes matter because cold exposure can turn quickly into a life-threatening emergency. Even a simple transfer requires helmets, lines, survival suits, radios, and a backup plan if the ice shifts underfoot. Returning to port after an Arctic mission does not mean the work is over. When Healey arrived in Baltimore, the ship represented months of endurance, science support, and ice operations, but maintenance had to begin immediately. Divers and inspectors may examine the hull, propellers, intakes, and underwater fittings in freezing conditions. Cold water dives require dry suits, safety lines, backup divers, surface tenders, communications, and careful timing. Because equipment failures underwater leave little room for error. The most dramatic repair came after Healey suffered a fire in a main propulsion motor in 2020. The damaged motor had to be removed, and a replacement was transported from the Coast Guard yard in Baltimore through the Panama Canal to dry dock in California. Workers cut into the ship's double hull, used cranes and rigging to remove the massive component, installed the replacement, and sealed the ship back together. It was not a simple engine swap. It was surgery on an icebreaker, proving that the ship's Arctic mission depends on hidden industrial work as much as frozen water bravery, and that every successful polar voyage begins with machinery trusted enough to fight ice for weeks. The same discipline also protects morale, because meals, watches, repairs, science schedules, and emergency drills all continue while the ship pounds through ice, far from quick rescue or easy spare parts. In that environment, reliability becomes the first safety system aboard every day. Healey explains Arctic science, but the Coast Guard's heavy icebreaker mission becomes clearest in Antarctica. USCGC Polar Star supports Operation Deep Freeze, the annual effort that opens access to McMurdo Station, the main American logistics hub on the continent. During deployment, the cutter breaks a channel through sea ice so supply ships can reach the station with fuel, cargo, food, vehicles, construction materials, and equipment needed for the research season. The mission is not simply sailing south. It is a months-long test of engineering, seamanship, and endurance, carried out thousands of miles from ordinary ports and under pressure from weather that can close quickly. Underway operations begin with route planning, machinery checks, drills, and constant watch standing. The crew tracks weather, ice, navigation hazards, and the condition of aging systems under stress. Icebreaking is demanding because the ship must repeatedly ram, crush, back, turn, and push through heavy ice. Engineers watch shaft lines, pumps, generators, engines, temperatures, and alarms. Deck teams handle lines and equipment in freezing wind. Cooks feed the crew around the clock. Medical, supply, communications, and damage control teams keep the ship ready because there is no nearby repair yard in the Ross Sea. The risks are real. During one Antarctic deployment, Polar Star developed a shaft seal leak, a dangerous problem because the shaft connects propulsion machinery to the propeller outside the hull. If seawater enters through that area, the crew must control flooding while keeping the ship operational. The response begins with alarms, investigation, isolation, pumping, and engineering assessment. Leaders decide whether the ship can continue, slow down, or needs immediate repair, while watch teams keep the Ice Channel mission moving. Coast Guard divers later repaired a leaking shaft seal in McMurdo Sound, where water temperature, ice, and limited time made the job difficult. Divers enter the water with cold water suits, safety lines, tools, and support crews monitoring every movement from above. They work around the stern, locate the problem, position repair material, and secure the seal while the ship remains in a remote operating area. It is dangerous maintenance in a place where weather can stop work quickly. Operation Deep Freeze depends on this kind of effort. The icebreaker must not only break ice, it must survive its own deployment, repair itself when possible, and keep the supply route open for science and national presence in Antarctica. Every repair buys time for the mission safely. When Polar Star reaches McMurdo, the mission shifts from icebreaking to logistics. For decades, McMurdo used floating ice piers reinforced with materials to support cargo operations at Winter Quarters Bay. After about 30 years of service life, an aging 30,000-ton ice pier had to be moved aside so a safer offload system could support resupply. Polar Star helped push and tow the expired pier away, using lines, controlled movement, and careful ship handling to reposition a structure made from ice, embedded material, and years of Antarctic use. The move demanded patience because the pier itself was massive, fragile, and surrounded by ice. The replacement involved a modular causeway system, a temporary pier made from connected floating sections. Army and support crews offloaded modules, aligned them, joined them together, anchored the structure, and created a working path for cargo movement. Vehicles and containers could then move from ship to shore without depending on the failing ice pier. After cargo transfer, the causeway had to be dismantled, lifted, and loaded again. This temporary system shows how Antarctic logistics works. Build what the season requires, use it carefully, then remove it before ice, weather, and time damage the equipment before crews depart south. The reason these ships fight through ice is not only military presence, much of the mission supports science. The National Science Foundation manages the U.S. Antarctic program, which enables research in one of the coldest, driest, and most isolated regions on Earth. Scientists study climate, ice cores, oceans, atmosphere, geology, biology, and the history locked inside layers of snow and ice. Every sample requires transport, shelter, power, food, safety, and a supply chain that stretches from American bases to remote camps. At a North Greenland Eemian ice drilling station, the work begins with a camp built around a deep scientific question. What can ancient ice reveal about past climate? Researchers prepare drill equipment, lower tools into the borehole, recover long ice cores, handle them carefully, and store them for analysis. Each section of ice can contain trapped air bubbles, dust, volcanic traces, and chemical clues from thousands of years ago. The process requires clean handling, temperature control, labeling, and patience. A mistake can damage evidence that took nature centuries to preserve. Aircraft make this science possible. The 109th Airlift Wing of the New York Air National Guard operates LC-130 ski-equipped aircraft that can land on snow and ice. Before takeoff, crews inspect skis, engines, propellers, cargo, fuel, radios, survival gear, and weather. Loadmasters secure pallets, passengers, and science equipment. Pilots review runway conditions, whiteout risk, navigation, and alternate plans before launching. At remote places like Camp Raven or Antarctic stations, the aircraft may carry food, fuel, researchers, tools, and replacement parts. The connection between Healey, Polar Star, ice piers, causeways, and LC-130S is one long logistics chain. Icebreakers open routes through frozen seas. Temporary piers receive ships. Aircraft reach inland camps. Scientists gather data from places that would otherwise remain unreachable. Inside America's biggest icebreaker story is a larger lesson about polar operations. The ship may break the ice, but the mission is to keep science, rescue, and national access alive, where the environment is always stronger than the people challenging it. In polar regions, logistics is the bridge between curiosity and survival, and every movement matters every season. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. Thank you.